Okay then my friends, in the last lesson we saw a bunch of different matches that we can use for making assertions, like to equal, to contain, etc. But the tests themselves that we wrote, well, they weren't overly useful. I was just making dummy tests to show you those matches and how they work. So I've deleted all of those tests, and in this lesson we're going to write some more useful ones for a function like the isPrime one. Now to get us started, I've already written some test cases out, and we're just going to work through these one by one and fill in the blanks. And as a little exercise, it might be a nice idea for you to pause the video before we write each one and just have a little go yourself at writing the assertions and seeing what you come up with, and then you can check your work against mine. So then let's start with this one right here, which says it treats 0 and 1 as non-prime and 2 as prime. So right here, we're testing just the first three small numbers, 0, 1, and 2, right? And we're saying that the function should return false for 0 and 1 because they technically aren't classified as prime numbers, but then 2 is the first prime number, so that should return true. So if you want to try this yourself now, pause the video and just give it a go. Alright then, so let's flesh this out. I'm going to start by creating a new expect function where we pass in a call to isPrime directly, and we're going to pass in 0. Now, what would we expect this to be? Well, we'd expect this to be false, right? Because 0 is not a prime number, and if we pass something that's not a prime number into isPrime, then it should return false. Alright, so let me duplicate this a couple of times, and the next one we're going to pass in is the number 1. And again, 1 is not a prime number, so if we pass 1 into the function, we would expect that to be false, the return value of this. So we'll keep that as false. And then finally, number 2. Now, number 2 is a prime number. It is the first prime number, so we would expect it to return true in this case, this function, and we'll change this to be true. So let me save that now, and if we come back to the terminal, hopefully we can see everything is passing. So this test right here has got a green tick next to it, meaning it's passing. Awesome. Alright then, so let's move on to this next one, which says it returns, that should be returns, and false should be 4 here. So it returns false for all even numbers greater than 2. Yeah, so any even number greater than 2 is not a prime because they can all be divided by 2. So let's do some assertions right here. We're going to say expect, and then we'll pass in a call to isPrime, and we'll pass as the argument a low even number like 4, which is not a prime number, so we would expect the result of this to be false, right? Because that's not a prime number. Alright, so let's duplicate this down a couple of times. Let's try 2 more. We'll say 10, and we'll also say 100. Alright, so I'm going to save this now and just check on the test results to make sure everything is passing. And yep, everything is still passing. In fact, what I'm going to do is just run this again because it stopped running for whatever reason. So npm run test. And yeah, we can see that everything is still passing. Awesome. So let's move on to the next one, which is this. It identifies common primes. So common primes might be things like 3 and 5, right? So let's do some tests or assertions for that rather. We'll say expect isPrime, and then we'll pass in the number 3. Well, that is a prime number because it can only be divided by 3 and 1. So we'll say to be true, right? So let's copy this down onto the next line, and we'll do another one, 5. And save that. And now if we open up this, we should see everything still passes. Yep, right here. Awesome. Alright, so now let's move on to the next test case down here, which says returns false for perfect squares. So perfect squares are numbers like 49, which has a perfect square of 7 because 7 times 7 is 49. And all those numbers which have perfect squares, they're non-primes, and for that reason in the function logic itself we only iterate up to and including the square root of the number we pass in. So we want to make sure that numbers with a perfect square like 49 return false reliably. To do this then, we'll make a new assertion using the expect function, and for the argument we'll pass in the isPrime call, and we're going to pass in a number like 49 as the argument. And then on this, we can chain the to-be matcher to say the result of this call should be false. Okay, cool. And then we'll try one more example. So I'll copy that assertion down onto the next line, and I'll just change the 49 value to be something like 121, which has a perfect square of 11. All right, and now hopefully those two tests should both pass because 49 and 121 are not prime numbers. So let's save this and open the terminal. And we should see that everything is passing. All right, so let's move on to the next one down here, which says it returns false for non-integers because naturally non-integers like 2.5, for example, cannot be prime numbers. Only whole numbers can be primes, and we want to check that functionality. So to do this, we'll say expect again. Then we'll pass in the isPrime function call, and we'll use 2.5 as the input. And we'll add on the to-be matcher right here to say that the result of this should be false because we know 2.5 is not a prime because by definition prime numbers can only be whole. So then if we save this and then open the terminal, we should see it pass, right? But, well, we don't. We see that the test fails. And that means something inside the function isn't working as expected. So this is one of the reasons we test our code, to catch scenarios where the expected behavior fails, so that then we can head back to the code and correct it. So if we head back to the function, we can see that there's nothing in this code that says the input number must be a whole number, an integer. And if we passed in something like 2.5, then this loop is still going to run, and the modulus of a decimal number won't have a zero remainder, so it's not going to return false from this function, and instead we will reach the end of the function and just return true for a decimal number. So then, we need to always return false for any non-integer numbers, and we could do that little check before the loop near the top of the function. And I'm just going to paste this in up here, and all this line of code does is check the num argument is an integer, and if it's not an integer, it returns false. So now if we save this file and open the terminal again, we should see that all the tests now pass. Okay then, so if we go back to the test file, we can see there's one more test case down here which says it throws an error for non-number inputs. So I think we actually did this same test in the last lesson, and now we're just going to quickly add it again. And remember, when we call the function with the expectation that it's going to throw an error and we're testing that throw, we need to wrap the function in another one so that it doesn't get executed before we even get to the assertion. So let's say const, and then we'll call this bad call. We'll set that equal to a function, and that function is going to wrap the isPrime function. And as an argument to the isPrime function, we can pass in a non-valid argument like a string Pikachu, for example. So we would expect this now to throw an error, right? Okay, so down here we can say expect, and then we're going to pass in the bad call function without invoking it, remember. And then at the end, we can chain on the to throw matcher. And I'm not going to pass in an argument for the error message because I just want to check that an error message gets thrown, or an error gets thrown rather. So then let's save this now and then open the terminal and make sure the test passes, which hopefully we'll see that it does. Okay then, so now we've written some better tests for this isPrime function, which actually means something this time. And now what I'd like to do is move on to a new function, which I've already copied from my course files on GitHub, and I'm just going to paste that into the examples.js file beneath the isPrime one. So this function, called shipping cost, takes in two arguments. And this time we have a weight, which is meant to be a number, and a coupon, which is meant to be a string, and the default value for that coupon is just an empty string value. Now inside the function, we do some type checks to make sure the arguments are the correct types. And things like this, by the way, would probably be less essential when you're using TypeScript and you give those arguments types, because the TypeScript compiler would catch those errors during development. But we're not using TypeScript, so we're going to keep these in. Anyway, then we throw an error for weights less than or equal to 0 because no parcels can have a negative weight. Then inside the function we do a little coupon code check as well to see if it equals free shipping. If it does, then we return 0 for the shipping cost. After that, we do some checks on the weight and return the cost values based on that weight. So for weights less than 1 or equal to 1, we return $3.99. For bigger weights less than or equal to 5, we return $5.99. For weights less than or equal to 20, we return $8.99. And for all larger weights, we return $14.99. Okay, so that's the function. Now let's head back to the test file and set up a new test suite for the function so we can write a few tests for it. And we'll do that right at the bottom below the other ones by using the describe function. And as a first argument, we'll pass the string examples.shippingCost, which is the name of the function, right? Then as a second argument, we can pass in a function to write all of our test cases inside of. Now next up, we also need to import the shipping cost function. So let's come up here and add that to the import statement, shipping cost. All right, cool. So then we're going to write some tests now, and I want to use this exercise as an opportunity to also talk about a few other things along the way to help you write better assertions. So first of all, I'm going to paste in a test case which checks if the function returns a number. And this is a valid test because it should return a number, right? So all we do is pass the function call into the expect function using 2 for the weight, and we say that it should be a number type. And this should pass, which we can quickly check by saving the file and opening the terminal. However, it's what we'd call a very loose test, and it doesn't really tell us much about whether the function is actually doing the right thing, just that it's returning some number. In other words, the test passes even if the function returns the wrong value, as long as that value happens to be a number. So while it's technically correct, it's not very useful for catching real bugs. What we really want are stronger, more specific assertions, ones that test what number gets returned, not just that it is a number. So I'm going to comment this test out, and instead I'm going to paste in a better test, which is this one right here, which says it charges correct prices for interior weights. And by interior weights, I mean weights which fall somewhere in the middle of the cutoff point, right? And inside this test case, we've got a few assertions for function calls using different weights, and we've specified exactly what values or prices we expect to be returned from those calls. And in most cases, a test like this would be better because it's not as loose, and when an incorrect price is returned, well, we'll know about that. So let's save the file, open the terminal, and make sure that all the tests pass, which hopefully they should do. Alright then, now that we've tested some interior weights, which are values comfortably inside each price band, I want to focus on the edges of each price range. And when we do this, when we're testing the very edges or cutoff points where the outcome is expected to change, it's called boundary testing. We're testing the boundaries of where one condition or outcome ends and another one begins. And a lot of the time, these boundary tests can be really useful to make sure those transitional points work as expected. In our case, the function jumps to a new price return at certain weights. So those cutoff weights at the boundaries of those switches are what we want to test. So then, if we take a look at the function, we can see these are the weights at the upper boundary of each pricing tier. And so they're the weights that we want to test. Let's head back to the test file then, and I'm just going to paste in this next test case, which says it charges the correct prices at the boundaries. And then inside this, we've got 4 different assertions. One at the upper bound of the first pricing tier, then at the upper bound of the second, then the third, and then finally 21, which is just above the third tier boundary. And we specify what each of these return values should be. So then, hopefully this should all pass when we save, but let's open the terminal just to make sure. And yep, we can see they all pass. Awesome. Alright then, so let's move on and put in another test case. And in fact, first, let's go to the function, because now what I'd like to do is I'd like to test this coupon behavior, which is an empty string by default, so it doesn't really do anything. But I want to see what happens when we actually pass this free shipping coupon in. So I'm going to paste in a new test case down here that says it applies free shipping coupon exactly. So we have 2 assertions where we invoke the shipping cost. We just try it with different weights just to make sure it works with both. And we pass in the free shipping coupon in each case. And we expect the shipping to be 0 because we return that value right here, don't we? So let's save this now and check out the results. And yep, we can see that that works. Awesome. All right then. So now I want to test what happens if we pass in coupons that don't work, basically. So I'm going to copy another test case from my course files, and I'm just going to paste it down here. I'm not writing all these out from scratch because I realize this is a long lesson, and to write all these out from scratch would take me a long time. So this one right here says it ignores non-matching coupons. So again, we have 3 assertions this time. They all invoke shipping cost, and they all pass in 1 as the weight. Now, if I pass in free shipping, which is lowercase, not uppercase, then I would expect it to be $3.99 because we're matching against uppercase, right? Now, if I pass this one in, I would still expect it to be 399 because this is not valid. And since the weight is 1 in both of these examples, that's why we return 399. And then finally, if we pass nothing in, then we would expect that to be 399 as well. So let's save this and take a look in the terminal. And yeah, they all pass as well. Okay, so now I finally want to test the errors that should get thrown when we pass in the wrong type of data for the arguments. For example, if the weight input was a minus number or a string, or if the coupon was a number or null. So we're going to write 2 different test cases for these errors because we're testing 2 inputs separately, the weight and then the coupon. So we'll start with the weight then by using the it function, and then as the first argument we'll say it throws an error for valid weights. All right. And then for the second argument, we need a function to write our test in. Okay, so now we can write an assertion for this by saying expect and then parentheses. And remember, when we're checking that an error gets thrown, we need to wrap the function call within another function first so that it doesn't get executed right away. So let's add a function right here to wrap a call to the shipping cost function. And as an argument to the shipping cost function, we can pass in 0, which is an invalid weight because the weight must be over 0. So then we'd expect this to now throw an error, so we can tack on the toThrow match at the end, and as an argument, I'll provide the message which we should expect in this case. The weight must be greater than 0. Now then, if I was to save this file and open up the terminal, we should see all the tests passing, right? But we don't. And that's because the error message we asserted doesn't fully match the error message from the function. If we go and take a look at that function, we can see it's almost identical, but it's not quite because we added the word the at the start of it. So just that small detail is making the test fail. And this is an example of a test which might be considered too tight. So we've got a test which is too loose at the top right when we said that it should just return a number regardless of what number that was. But this one is completely in the other direction. It's gone too tight and too strict because do we really care about what the exact error message should be? Probably not, but maybe we do want to check for a keyword to be in that error. And we can do that by using a regular expression instead. So let me just copy this test first of all, and then I'm going to copy it out. And now I'm going to paste it in down here. And instead of supplying the whole error message as a string, we'll use a regular expression to match against the presence of a single word instead. So we can delete that string and replace it with a regular expression that looks something like this. /, then parentheses, then a question mark followed by the equal sign, then a full stop, then an asterisk, and then the word weight, followed by your closing parentheses. After that, we'll open the parentheses again and do the same question mark, equal sign, full stop, and asterisk, and this time add a 0 and the closing parentheses. And finally, we'll add the / again, then a lowercase I. Now, I don't want to delve too deeply into regular expressions right now because I want the focus to be on testing, but essentially this regular expression means there must be the word weight and the character 0 within the error message somewhere. And this I character at the end means that those things are case insensitive. So if weight is uppercase or lowercase, it won't matter so long as they're in the message. If you do want to learn more about regular expressions, then I do have a whole tutorial series about them on my YouTube channel, which I will leave the link to down below the video, and you can learn more about this kind of thing. Anyway, this should now pass because the word weight and a 0 does appear in the error message. So if we save this file now and open the terminal, we should see that all tests pass. Awesome. Okay, so now let me just duplicate this onto the next couple of lines so we can test 2 more invalid weight inputs. So then I'll change the first one to a minus number, like -5, and for this we can keep the same regular expression for the error message. And then for the next one, we'll pass in a string as the argument, like the string to instead of the number, and this time we'll change the regular expression to look for the word number instead of 0, because when we pass in a string argument for the weight, we get a different error message saying that the weight should be a number. Okay, so now we can save this file to rerun all the tests, and hopefully when we open the terminal, we should see them all pass. Alright then, so there's one more thing we're going to test now, and that is the error that gets thrown when we pass a coupon that's not a valid input. So let's use the if function again and invoke it. And for the first argument, we'll pass the string throws when coupon is not a string. Alright, so we're going to throw an error, or we expect an error to be thrown when that coupon input is not a string. And then for the second argument, we pass in the function. Okay, so what I'm going to do is now just paste in two assertions, so you don't have to watch me write these out from scratch. And these two assertions run the function with a weight of 1 and then have invalid coupon values, a number for the first call and null for the second call. Now, in both of these cases, we expect an error to be thrown, and in the error message, we're simply looking for the word coupon to appear at some point. So let's save the file then and open the terminal to make sure these latest tests pass, which they should do. Awesome. Alright, so we've had a lot of practice now writing different kinds of tests using different matches, and we've also looked at boundary testing briefly, which can be really useful, as well as tests which are too loose or too tight, and we've looked for that middle ground Goldilocks test instead. So hopefully you're getting the hang of these tests now and the different things we can test, and in the next lesson we're going to look at a slightly different way we can write these test cases and assertions.